All right, so moving on to like multiplying exponents, paying attention to parentheses. We're just going to do lots of examples with exponents to simplify things like that. Okay, so hopefully you've learned about this with just numbers, and now we're doing it with the variables, right? So as we saw before, right, I'll draw a separate line. Right, so if you have x squared, that means 2x's, right? If you have y to the 5th power, that would be multiplying y 5 times, okay? You might have something like this, x squared, y to the 5th. So if you remember, when you have like variables right next to each other, first of all, that means you're just multiplying them together. And if you were going to write it all the way out, that would be x squared, so it's 2x's, times 5y's. Okay? You might see it go the other way. Right, so let's say we have you can see why we want to have exponents, right? Because like writing this all out is not very practical. So instead of writing it out, we can have our shorthand. Let's write it in an exponent form. So we have to figure out, right? Because remember, an exponent is specifically for repeated multiplication. So I can't write one exponent for this whole thing. I'm going to undo that line. I need to look first at this set, at the x's, the ones that are the same, and then I'm going to look at these that are the same, and then I remember that they're just being multiplied by each other. Right, so I'm going to count my x's, 1, 2, 3, 4, 5, 6, 7. So that means x to the 7th power, right? The base is the number that's repeating. The exponent is how many times it's repeated, which is 7 times. Right, and then y, I have 1, 2, 3, 4. So x to the 7th times y to the 4th power. Nice and shortened. Okay? And sometimes you might see something in different orders, right? So I'm going to use a and b now. So maybe it's a times b times b times a times a, something like that. Right? So if you remember the commutative property of multiplication, right? That means I can multiply in any order that I want, right? So I can rearrange this whole problem to put all of my similar bases next to each other, right? Because remember, commutative property of multiplication, right? Like 3 times 5 is equal to 5 times 3, right? It doesn't matter what order I do this in, and that's for any long string of multiplication like this, right? So instead of saying a times b times b times a times a times b times a, I can rewrite it. So I'm going to say that a times a times a times a. So I got all my a's, and then b times b times b, so it's 3. Right, so I rewrote it in a different order. That way I like to do this so that I can lump together my bases, the ones that are the same, right? And then I know I have a to the 4th power times b to the 3rd power. And you don't really need this dot here, but it's not wrong if you put it too. Right, so that's one example of the commutative property. You might just do it in your head. Totally fine. You don't need to put them all next to each other like I did here. Maybe you just count the A's. Oh, I've got 4 A's. I've got 3 B's. But just know that in essence, you have done the commutative property. You just did it in your head to get to your answer. And I always just, when I do math examples, I do every single step just so you know how we got from point A to point B. Okay, so that's a commutative property. exponents, it's multiplication, so you can do it in any order, and we did that to simplify it to this nice, this nice example. Okay, so now I want to kind of throw in some parentheses because it gets a little confusing. Parentheses has to do with grouping, and that's really important when it comes to exponents. So let's say you have AB in parentheses times AB in parentheses. So if you remember the associative property, right, that's when you can actually, in multiplication problems, you can take away the parentheses, right? So 5 times 3 times 2 is the same thing as 5 times 3 times 2, right? I actually don't need it. So if I were going to rewrite this, sorry, I'm going to kind of skip. Remember, it's just purely a multiplication problem. I can just rewrite it as A times B times A times B, right? And that leaves me with A squared, B squared. Okay, so the reason I want to bring this up is because another way you might see it written, right? Well, you could think of the AB as a base, right? And we're repeating AB times AB. That means you could say AB squared. These two are actually the same thing. So either way you want to do it, if you like the using the associative property way, you like this way, this is correct. If you want to kind of do it more like the exponent way, where you see the repeating base and then you square it, or depending on how many there is, you'll put the right exponent. This is also the right way. But I want to bring this up because what a lot of students sometimes do, so this is going to be the wrong way. I'm going to do it in a different color just to emphasize that. So this is the wrong way. Students will be like, okay, this is repeating, and they'll just say A, B squared. This is actually different when you think about, remember how two variables next to each other is multiplication. What this essentially means is A times B squared. Okay, you're not saying, oh, all of AB squared. You don't have that parentheses that you do up here that groups them together. You're only squaring the B, right? So you can see you get a different answer. Right up here you can see it's A squared times B squared. This one is just A times B squared. This is not the same thing. This is the wrong way. Okay, so those parentheses, you have to really pay attention to them. That's why sometimes I just like to use the associative property if I'm gonna be doing exponents, and I've got a lot of things in parentheses multiplied by each other. I'm like, okay, let's just take away these parentheses because they make it more complicated, and we'll just multiply it, like this. But if you're going to keep it in this form, like here, you have to remember in your final answer to keep your parentheses, because you get a completely different answer if you don't. And we can actually prove that. So let's prove that these are different. So first let's prove that these two are the same. Okay, so let's just say A equals 2. So you can prove anything. You can set numbers to variables, and you can prove if things are the same or different. Right? Proofs are really useful. That's what we use to derive formulas, all the formulas that you use in algebra. Right, so I'm going to prove that A squared times B squared is equal to AB in parentheses squared. Okay, so I'm proving that these two are the same, which I've already said they are, right? So let's prove it. You can pick any two numbers you want as long as they're consistent. I'm just picking small numbers because I like to do it that way, right? So if I plug it in, substitution, plug it into A, plug this into B, right? So I have 2 squared times 3 squared, right? 2 squared times 3 squared. 2 times 2 gives me 4. 3 times 3 gives me 9. 4 times 9 gives me 36. Right? Okay, so now let's do the other side. So I'm plugging 2 into A, 3 into B. So I have 2 times 3, and then you square the whole thing, right? It's in parentheses. Right? 2 times 3 is 6. We square 6. 6 times 6 is 36. So you can see we got the same answer. We prove that this is true. We prove that a squared b squared is equal to parentheses ab parentheses squared. Okay, so this is true. We proved it. You're not going to do proofs in your homework. I'm just doing it to show you all how these two are the same answer, even though they look different. Okay, now let's prove that they're different from that wrong example. Right, so let's prove that we can pick either one. I'm gonna pick this one. Let's prove that AB squared does not equal, so you have an equal sign, you can put a line through it saying they do not equal each other, A times B squared. Okay, and I'm going to use my same, A is 2, B is 3. Right, so 2 times 3 squared. We already know this equals 36. We did that one. Right, so if we have 2 times 3 squared, right, that's different. We're not squaring the A this time. So we have 2 times 9, 18. 36 does not equal 18. So, right, this is true. They are not equal to each other. That's why you can see this whole, I don't really like to do like how to do it the wrong way examples because I don't want to confuse you, but I just really want to emphasize the importance of like parentheses. They can completely change the meaning of a math problem. This is why PEMDAS is so important. This is why we're always like deal with the parentheses first, because they change the whole meaning of a problem. So these two are your right way. If you're going to do it, if you're going to do it this way, you have to remember the parentheses. Okay, long-winded. So let's just do more examples like that, right? Let's just do lots of like exponent examples just to, we'll do some with parentheses, some without. So maybe you're asked to write this out in a long form, right? So this is 2 times x to the 4th. So you can write that as 2 times x times x times x. Okay. Maybe you've got 2x to the 4th. This is different, right? Because we've got this in parentheses to the 4th power. So that means it's 2x times 2x times 2x times 2x. And you can actually, I'm going to write this in a million steps. I'm going to take away my parentheses, right, using the associative property. And then again, I'll write it in more steps. I'm going to rearrange it using the commutative property. Right, and then I can multiply this together. I don't have to write this in exponents. If I just plug it into a calculator, I'll get 16. And then I get x times x times x times x. Or you can write it as 16x to the 4th. Right, so you can see we got from here to here. This is actually kind of more the preferred way. Because if you have a number in there that you can deal with and make it simpler, math, we want to try and make everything as simple as possible, right? So I could deal with that too. Yeah, 3x times 2x looks different. They're not the same base, right? 3x and 2x, they're not the same. So instead, I'm just going to use associative property. Right, and then I would use commutative. I can multiply that together, so I get 6, and then x times x is x squared. Okay, so that's my answer there. Sometimes you might have something like this. There's actually a shortcut, so we'll do it the long way, and then we'll go over the shortcut. Okay, so say you're multiplying two exponents, but they have the same base, right? So let's write this out the long way. I want to try and combine them. So I have x to the 4, so that's 4x's times x to the third, 1, 2, 3, right? And then I can actually combine them. 1, 2, 3, 4, 5, 6, 7. Right, so I multiplied two exponents with the same base. I can combine them and I get x to the 7th power. If you notice the pattern, what is 4 plus 3? 7, right? So it's a nice little shortcut so that you don't have to, if you prefer to write it out, if you like doing all the steps, go ahead. But if you like the shortcut, then that means you don't have to rewrite the whole thing. So it's especially useful when you have like big ones, right? So like x to the 9th times x to the 12th. I don't want to write 9 x's and then 12 x's and then add them all together. I can just use the shortcut. 12 plus 9 is 21. And I just get x to the 21st power, right? A lot simpler. So maybe you have okay, you notice they don't all have the same base, right? But these two have the same base. If it helps you, you can use the commutative property, write them all next to each other, right? These two have the same base, so that means I can add their exponents together as a shortcut. And I get this as my answer. For good measure, I'll do this one the long way. Right, so I did the commutative property to rewrite it in any order I want because I can do that with multiplication. X squared is x times x, right? X to the 4th is x times x times x times x. And then y to the 3rd, I'm just going to leave it the way it is because I can't combine the exponents with x, right? I count my x's, 1, 2, 3, 4, 5, 6. I get x to the 6th, y to the 3rd. So you can see I still come up the same 1. Yeah, so that's just a nice little shortcut if your bases happen to be the same. Okay, so you don't have to write these whole long things out. And then, sorry, this one's coming out to be a little bit longer of a video. I just want to go over if you have a negative base, okay? Right, so if your base is negative, pay attention to whether your exponent is even or odd. Oops. Okay, so let's say your base is -2, right? And then we square it, right? So then remember we're saying -2 squared, right? So -2 times -2, and that gives us +4, okay? So let's say we have an odd exponent. -2 times -2 times -2. That gives us, if you want to write out the steps, -2 times -2 is +4, right? Carry that down. 4 times -2 is -8. So you can see I have a -1, right? So if your base is negative, if exponent is even, answer will be positive. If exponent is odd, your answer will be negative. Okay, that's just that handy little rule. This is another example though where the parentheses is important. Again, those parentheses really change a problem, right? So let's say I have negative in parentheses 2 squared. This means if the exponent is outside of parentheses, that means I'm only squaring what's in the parentheses. Okay, so this negative is not squared, it's outside. So it's actually like -1 times 2 squared, -1 times 2 times 2, and then we get negative, 2 times 2 is 4. We get -4. So you can see how that's different from this up here, because where our negative is, whether it's inside or outside the parentheses, it's going to change the your answer, right? This one was +4, this one was -4. So again, it's just those tricky negatives. Make sure you pay attention to where it is in the parentheses. But otherwise, hopefully exponents make sense. You don't have to do, like remember this rule here. You can just write it all out. It's just a nice, I'm always trying to give you all shortcuts, but then there's a lot of shortcuts to remember. As long as you know the basics of exponents, then you don't need to remember the shortcut. You can still just write it all out, and you'll get the right answer.